On October 20, 2020, NASA's OSIRIS-REx spacecraft collected a sample of asteroid Bennu. The event revealed surprising details about Bennu's surface and near subsurface. At approximately 11:30 a.m. Mountain Time, the spacecraft departed orbit. A few hours before, mission controllers on Earth had sent the commands for the Touch-and-Go Sample Collection Maneuver, or TAG. OSIRIS-REx made its final descent to the primary sample site Nightingale. With its sample collection arm outstretched, it approached the surface of Bennu at 10 centimeters per second, the walking pace of a spider. Scientists had expected that the TAG event would have little impact on the asteroid. After a slow descent, the sampler head would briefly make contact, inject a puff of gas, and capture a handful of material. Perhaps it would also leave a subtle footprint at the sample site. But the impacts were far more dramatic than anticipated. Despite its slow touchdown, OSIRIS-REx had punched through the surface and set off an explosion of loose material. Tons of rocks and pebbles were ejected, radiating outward in a wall of debris. 1 second after contact, OSIRIS-REx released a canister of pressurized nitrogen, detonating an explosion of particles and driving material into the head of the sample collection arm. 6 seconds after contact, while it was still sinking into Bennu, OSIRIS-REx fired its thrusters to begin the back-away maneuver. The engine burn lasted for 24 seconds, continuously pushing against the spacecraft and rapidly slowing its descent. Flying debris from the thrusters and the gas release pelted the science instruments, clogging them with dust. 9 seconds after contact, when OSIRIS-REx had sunk nearly half a meter into Bennu, it reversed course and began to rise. At 16 seconds, the head of the sample collection arm re-emerged from the subsurface, as the spacecraft continued to accelerate. 30 seconds after contact, OSIRIS-REx shut off its thrusters and drifted away with its sample of Bennu. A later observation of the point of impact showed a new crater averaging 8 meters across and reaching 68 centimeters in depth. Thruster marks overlapped with this TAG crater in an X pattern, increasing its volume by as much as 40%. A ridge of ejected material that had been kicked up during sample collection and fallen back to the surface circled the crater like a campfire ring. Scientists had expected cohesion to act like a bit of glue between the rocks on Bennu, making its loose surface more solid. But the TAG event showed that Bennu's uppermost layers are nearly cohesionless, deforming under stress like a fluid. A good analogy is a ball pit. Although the plastic balls are solid, they easily slide past one another and past boisterous children, behaving like a fluid. Thanks to OSIRIS-REx, we now know that Bennu's surface is held together by microgravity, with a minute tug less than 100,000th the pull of Earth. Bennu has consistently defied scientists' expectations, as each new finding reveals another facet of this small but surprising world. 2 days after touching down on asteroid Bennu, OSIRIS-REx verified the status of the sample, using a camera called SAM-CAM. This visual inspection revealed whether any large debris was still attached to the sample head, which could pose a hazard during stowage. NASA's OSIRIS-REx mission team confirmed that the spacecraft had collected more than enough material to meet one of its main mission requirements, acquiring at least 60 grams of the asteroid's surface material. On October 28, 2020, OSIRIS-REx closed the sample return capsule, marking the end of one of the most challenging phases of the mission. After a final departure maneuver in May 2021, OSIRIS-REx began a 1.2 billion mile journey back to Earth. We hope you enjoyed the video. Be sure to hit that like button and subscribe to our channel. See you in the next video.